Welcome back to this channel. Today we are looking at some past questions and what is required of students. So today it's basically the computer applications past question for April 2025. This very one is the regular session. So if you look at the first question, there was a diagram which involved an op amp. There was a feedback resistor, a load resistor, an oscilloscope, an input resistor, and then an input signal. And the question was basically identify, name, and explain the circuit in figure 1.1, stating the various equations associated with it. So if you look at an op amp of this nature, you realize that the signal, it is the negative input or the inverting input of the amplifier that is biased. So that is basically an inverting amplifier. And then the various equations that relate to it continue. Okay, so you would find the various equations, that is finding the V naught, and then also the equation with relations to the gain. Now the next question was to calculate the expected peak-to-peak voltage. So the peak-to-peak voltage normally will be the voltage across R3, and the equation is given as R2 over R1 times that, and then you would get 5 volts. But because we are looking at peak-to-peak voltage, you would get 10 volts. Then it also said that the simulated output voltage is 5 volts. Compare it with the calculated voltage in B. What this basically means is that yes, the output voltage is 5 volts, but we got the peak-to-peak voltage to be 10 volts. What are your comparison? Okay, so basically that was what was demanded in question 1. And then in question 2, a diagram of a full wave rectifier was given with input voltage to the transformer, an AC input voltage to the transformer, and the transformer is supposed to be a step down transformer. And then there is a bridge rectifier, and then there is a load. Now the question is, write a MATLAB program using if, n, and for loop to simulate the full wave rectifier in figure 2.1. The code must include, first, defining a time vector for your simulation. So you have to define the time vector, set up equations for primary and secondary voltages, rectify input signal using the if, end, and for loop, and then plot AS input and rectified output voltages. So when you look at this, first of all, we have the primary side voltage and we have the secondary side voltage, and we have the frequency. These are all declaration of variables. And then the frequency has also been declared. Then a formula for time, which is T, has also been declared. And because we already have frequency to be 60 Hertz, once you initialize T equals to 1 over F, that will give you the period. Okay, now we do dt equals to this, and then that is what is going to give us the time intervals. Okay, so you realize we said define a time vector for a simulation. So we are taking the time interval from 0 or the time from 0 with intervals of dt to t. That is for 2 cycles. And then we have E1, which is Vs times sine 2 pi. And then the length of this, then we do the rectification. So you see the equation. So for, we are asked to use the for loop. And we are also asked to use the if end. Okay, so you would see that for n equals to 1 is to length, that is the length of E1, then E1, if E1n is greater or equals to 0, then E2n is equals to E1 into bracket n, else negative E1 that. So once this is done, the remainder is just the basic plotting of that. Then we moved on to question 3, where you have a Simulink model that was used to generate the waveform below. So if you would remember in your Telecom 1, you would see that this was basically a frequency modulation diagram. Okay, so the question was to identify and name the model in figure 1. That's a Simulink model for frequency modulation. And then we're supposed to label the blocks, that is I, and I. So you have baseband signal, passband signal, scope, and then oscilloscope. And then you have to explain the principle behind frequency modulation briefly, looking at the marks that should inform how your explanation should be. And that was basically a simple exams. And then let's look at the same exams for the weekend students. That was in April 2025. So the first question was a multisim schematic, which is a digital electronic circuit, but the actual name of the circuit is there. So you see 3 AND gates, an OR gate, an XOR gate, and then you see 3 inputs, an AND and then an addend and then a carry, and then the outputs you have sum and carry off. So the question was to identify the circuit diagram, and it's basically a full adder. And then the next one was to explain the operation of the identified electronic circuit in figure 1.1. So that was what was expected. And then you were also asked to draw the truth table for the circuit operation. That is, when you look at the 3 inputs and then the 2 outputs, based on the binary inputs, a combination of zeros and ones. The first one is 000, 001, 00010, and then the corresponding output for the carry and then the sum. So that was basically what was expected. Now when you come to question 2, you would see that was based on MATLAB. And it says that give the steps to solve the following linear equation using MATLAB. Now, when you take this equation here, basically what it means is that each and every one of the equations has some coefficients. So first of all, you declare all those coefficients into a vector. And then you create 2 variables, A and B. And then basically you find the inverse of A times B. And that would give you the solution of the equation. Then the second one was to write the command for drawing the curve, as you see here, and you are given some intervals, -5 to 5 and then -5 to 5 for x and y. Okay, so once you declare -5 is to 0.1, that will be the intervals, up to 5, and then the Y as well. Then AB, you use mesh grid, and basically this is what was expected. Then the second one was, suppose S is a new variable with the following MATLAB command. So the question here is that write the following MATLAB command. What is the size of X? So basically you would see that when you look at this, you have negative 10 colon minus 1 colon 15. It means that you are generating negative 10 to negative 15 with intervals of negative 1 for one row, and then for the next row you are generating negative 2 to positive 3. But here you haven't defined any intervals. So what's going to happen here is that you end up having this section also generating 6 elements in that row. Okay, so you end up having the size to be 2 rows and then 6 columns. Then Ali went to the market. He bought so and so 5 10k resistors, and the cost was 4 cedis per resistor, 2 3 microfarad capacitors at 7 cedis per capacitor, and then 6 inductors, 2 for 4 cedis, and 6 diodes, 2 Ghana cedis each. You are to write a MATLAB code to compute the total amount. So the total amount is basically, you have 5 resistors and each is 4 cedis, so 5 times 4, and then you have 2 capacitors and the price is 7, so that times that. But here, because you have 6 inductors and 2 of them is 4 cedis, you have 6 divided by 2 times 4, and then you have 6 diodes, and then you have times 2, and that will be the equation. You are not asked to give the final answer. You are only asked to write the MATLAB command that would or the MATLAB code that would compute that. Then you also have this equation here, y equals to the absolute of x e raised to the power ax minus cos into bracket b x, and for a equals to 11, b equals to pi, and x equals to this. So you define all those variables, and then you just define y and write the equation for same. Then for question 3, the diagram here said that the figure below is an amplitude modulation Simulink, and you were asked to redraw and label the parts. Okay, so basically that was, so you have the baseband signal, the constant, and you have your carrier signal. You're going to be doing, because of the amplitude modulation equation, where you have the multiplication side or the sum and then the product, you would have to bring the product and then the sum, and then the oscilloscope also is here, which is to display the output of that. So basically you are asked to redraw, label the various blocks, and explain how amplitude modulation is done for 15 marks. And so these are just, and you were asked what is modulation index. So it's basically, it describes how the modulated variable of the carrier signal varies around its unmodulated level. And then we also asked what happens when modulation index is over 1. So that is also there for your consumption. So basically these were the simple answers that were expected for the computer application, both regular and weekend, for this just ended academic year.